Let's go over how to use the multimeter to measure voltage and current.
Before we turn it on, we're going to plug the black lead into the common ground. Then we're going to take the red lead and we're going to plug that into the side that says voltage, because we're going to measure voltage first. Now this is used for a lot of things, but right now we're going to set it to volts. Now if you look up here, there's different settings for voltage, and we want to start with something that's going to be higher than what we might expect so we don't burn out the meter. So I could go to, say, 40 volts and see what we get. We only have the one battery running this light bulb. Let's hook it up and see what happens. I've stuck the probes right into the little spring holders so I get really good contact. And as you can see, I'm getting 1.51 volts. And I've hooked up the meter in parallel. The current is flowing from the positive to the bulb and returning back into the battery here. The voltmeter measures the voltage difference from one point to another. So from the positive end of the battery to the negative end of the battery, I'm getting 1.51 volt difference. Now I've moved the probes to each side of the light bulb. I'm still getting 1.51 volt difference, and that's what you would expect. Now I've put one probe over by the battery and the other one by the bulb, and what I'm doing now is measuring the voltage difference across the red wire. Hey, I'm getting 0 volt difference because the wires essentially have no resistance. I have no voltage drop across that wire. Now I'm back where I started from, and we can see that we have 1.51 volts, but I'm on the 40 volt scale. What would happen if I turn to the 4 volt scale? Well, I get an extra decimal place. Don't try turning it to the 400 millivolt scale because we have more than that and it's not good for the meter. So you start high and you work your way low if you're not sure what level of voltage you're working with. So here's a question for you. Do you think the voltmeter has high resistance or low resistance? If the voltmeter has low resistance, the current wouldn't be flowing through the bulb so much, it'll be going through the meter. Well, we don't want that. All we want to know is how hard the charges are pushing here compared to over here. So we want to have a lot of resistance just to measure how hard they're pushing, but not let them through. It's like measuring the tire pressure on your car tire. You want to measure how hard the air is pushing, but not let the air out of the tire. To prove my point, I'm going to remove the red wire and use the meter to bridge the gap from the battery to the bulb. So I'm going to have the current going through the meter and then right into the bulb here. Let's see what happens. Well, I'm getting a voltage reading. There's definitely a voltage difference from one end of the meter to the other, but there's nothing flowing through. The bulb is not lit. That confirms that this meter has high resistance. Now that we have the voltage, let's measure the current. To play it safe, I've disconnected the probes. And now I'm going to set the meter to the 10 amp setting. That's as high as it'll go, and that should be pretty safe. But that means I have to plug the red lead into the 10 amp receptacle. And now, how do I want to measure this current? I need to count the charges going through the meter. So in order to count the charges going through the meter, I have to make the circuit not just go through the bulb, but through the meter as well. So I'm going to have to put a break in the circuit and insert the meter in series. One thing I could do is get rid of the red wire, put the red into the positive of the battery, and now put this into the receptacle for the bulb. And now the current is flowing through the meter and through the bulb and back into the battery, and we see we're getting 185 milliamps or 0.185 amps. Note that this meter is hooked up in series, so we can count all of the charges. It's kind of like when you go to a sports stadium and they want to know how many people are in the stadium. They need to have a counter so that people actually go through the turnstile and turn the turnstile. So that counts each person. That's what these charges are doing inside this meter. You have to put them all through there if you want to know how many of them you have. Since we have only 185 milliamps, we could switch to the 400 milliamp scale. First, I'm going to disconnect the meter. And then I'm going to take the red lead and I'm going to put it over here where we can measure milliamps. Right there, it says milliamps. Now I'll come over here and I'm going to turn this to the 400 milliamp scale. And I'll reconnect. Hey, we're getting a slightly different number than before. Well, that's because these meters aren't perfect. It's supposed to have low resistance, but it doesn't have zero resistance. So depending on the scale you are, you can get slightly different readings. Now here's a great way to damage your meter. Keep it on the milliamp scale and come over to here and connect the leads positive and negative right to the battery. Well, there's going to be no resistance here, very low resistance, and the current is going to surge through that meter. It's not meant to handle that. So do not hook this up directly to the battery without having a circuit completed with some resistance in it. Now let's do this all over again, but we'll do it with two batteries in series. To put them in series, I need to take the positive from the battery on the right and connect it to the negative of the battery on the left. I've used the short red jumper wire to do that. It's doing the same thing as taking this battery, putting it to here, and that's the positive to the negative. And then if I measure the voltage from one side to the other, I've doubled my voltage. Now, danger, danger, look what I'm about to do. I want to go measure that voltage. But I never changed my setting on the meter. I'm still on the milliamp scale. I'm about to hook it up to both sides of the battery there, and it's going to not be good for the meter. I've set the meter to 4 volts. Now I can insert the probes. And I get 3.19 volts, which is about double of what we had before with one battery. I hook up the wire from the positive end to the bulb. And now I'll complete the circuit with the blue wire going into the negative end. And the bulb is much brighter. Let's check out the voltage. As expected, it's a little lower because of the internal resistance of the battery. And if I measure it across the bulb, I get the same thing. And again, we'll measure current. I disconnected the probes. I'll set this to the 10 amp scale. I'll bring this over to here just to make sure that I don't burn out my meter. And now I don't need the red wire. I need to force all the current through my meter. So there goes the red probe. And now the current's going to go through the red, into the meter, out of the meter, into my black probe, and now into the light bulb. And I get about 260 milliamps. Yeah, I'd still be safe on the 400 milliamp scale. Now to measure current, the first thing I'll do is I'm going to disconnect the probes. Don't try changing the meter without doing that. And now I'm going to set this into the 10 amp receptacle, and I'm going to turn the knob to the 10 amp scale. And now I can take I'm going to take this wire right out. I got to put a break in the circuit if I'm going to measure current. So I can take this black lead, put it right here. And now I'm going to force all the current through the meter by doing this. I've put the meter in series. And yeah, I'm getting about 260 milliamps. Should be more current because I've doubled the voltage. Now you might think I should be doubling the current because I've doubled the voltage, but don't forget that light bulb gets hotter now, so its resistance is not the same as it was before. Well, from here you should be able to use your own meter, light bulbs, and batteries and build more complicated circuits and measure the voltages and the currents in all the components.